This video aims to inform existential threat of ozone layer depletion which we are all facing, simultaneously present a viable solution through the research, development, and manufacture of a prototype model of a drone requiring immediate implementation to mitigate ecological effects of CFCs or chlorofluorocarbons. Hi everyone. Yes, today I'm going to talk about the ozone layer. I think everybody's familiar with this term. So, what is ozone? According to Wikipedia, it is an inorganic molecule with the chemical formula O3 with a pale blue gas and a distinctively pungent smell. It is an allotropy of oxygen that is much less stable than the diatomic oxygen O2, breaking down in the lower atmosphere as dioxygen and absorbs most of the sun's ultraviolet radiation. After some time of browsing different websites and comparing articles, I found this definition to be consistent with one another. Thus, I feel confident about its accuracy. Oh, yes, by the way, I just want to point out that almost everything invisible can really mess up a person's understanding of a concept, including my idea on this subject. It's because you don't see it, if you know what I mean. You see, I've boarded airplanes a couple of times and all I saw was the clouds. Yet I never really appreciated how important this portion of the atmosphere staring at me at the face, whizzing around. Next slide, please. Now, this is what it looks like, microscopically, of course. So this sphere you see here is an oxygen atom. Okay, let me just place the pointer. This one. Okay. Central oxygen atom connected to two other oxygen atoms. Well, as a kind of heads up to the viewers, I would like to cite the ozone oxygen cycle involving the sun's UV radiation hitting the O3. So let's say this is the UV light of the sun. When it hits the O3, it breaks them up into O2. This is O2, two, two atoms of oxygen, and one atom here. Now, this ozone actually is what shields us from the effects of the UV from the sun. And then later, these two molecules, this one and this one, will recombine with other freed up oxygen and O2 molecule back into an ozone. So it will recombine with other, you know, oxygen floating around the atmosphere. Now the cycle repeats, giving an abundance of these molecules. But it's always never that easy, as other molecules that need consideration are also uh, present, floating around in the air, such as nitrogen, hydrogen, bromine, and also chlorine. Not to mention CFCs, the chlorofluorocarbons, which is the main antagonist in this discussion, the destroyer of ozone, the harbinger of death, the one that will start the apocalypse. Call it whatever you want. However, let me point out this early that CFC, if you think about it, it is actually easily broken down into its key components by the sunlight's UV radiation, like a vampire disintegrating when being hit by it. Chlorine actually is what destroys the ozone in the process. This one. Now the problem really is, and I want you all to keep this in mind, and this is important. When CFC is high above the stratosphere, it's actually harmless. But if CFC gets trapped below the ozone demarcation line, or the so-called troposphere, hell breaks loose, and all this wonderful ozone dies in the process. Yes, they all die. And we become defenseless from the deadly cosmic rays. Now, last thing to remember, winter months lowers ozone production. So, right now, we have two powerful powerful weapons or strategies to save the world. Number one, heat and UV light that will destroy the CFC. And number two, we have to bring CFC to the stratosphere. And how are we going to do that? Next slide. Okay. What is ozone layer, by the way? Is there a difference? Can you tell the difference? Okay. What is ozone layer? It's also called ozonosphere, region of the upper atmosphere between roughly 15,000 and 35,000 meters above Earth's surface, containing relatively high concentrations of ozone molecules. O3 is approximately 90%. The atmosphere's ozone occurs in the stratosphere 50,000 meters above the Earth's surface. The ozone layer effectively blocks almost all solar radiation of wavelengths less than 290 nanometers from reaching the Earth's surface, including certain types of UV and other forms of radiation that could injure or kill most living things. Again, you may pause the video for this slide, but I don't think most people could ever visualize what the ozone layer looks like or its behavior, even if they kept reading this definition or any other definition out there over and over again. However, the next slide will graphically illustrate what an ozone layer is. And this is what I'm talking about. When we talk about ozone or about layers, we are literally talking about layers, materials, or molecules at different heights above the Earth's surface. Troposphere starts at the ground up to 10,000 meters. So from here, follow the red arrow. here up to here is 10,000 meters. This is the troposphere, this one. All right. Now the stratosphere ranges from 10,000 to 50,000 meters, wherein the ozone layer lies somewhere in the middle region of the stratosphere at 25,000 meters. So this is stratosphere, the stratosphere. If you look at the line here, this height actually is the stratosphere. It encompasses the troposphere and the ozone layer. Now this is the ozone layer. This one is what protects us from the sunlight's UV radiation. This one. Yeah. See this airplane? Now, in the image, it is represented as the layer frequently traversed by airplanes. Now, the mesosphere goes higher from 50,000 to 80,000 meters. Mesosphere, this one. So from here to here, it's much higher than the stratosphere. This is the mesosphere. It's almost near the outer space here. Now, it's interesting to note that before we humans started spewing CFCs into the environment, there was this sublime, perpetual, and delicate balance of chemical reaction called ozone-oxygen cycle. Now, this is where sunlight kept knocking oxygen and ozone around safely, of course, exchanging ions and multiplying each other's volume each time. So the more ozone in the stratosphere or higher atmosphere, the better. Okay? Well, it's like a love that would last forever until the evil chlorofluorocarbon CFC came along, disguising itself as chlorine monoxide that kept destroying oxygen in the process. Fortunately for us, methane comes to the rescue and converts it to hydrogen chloride, which is then cast down into the sea. Methane is what kept us afloat, folks. Without it, we would all be dead by now. Still, the threat looms since another ozone hole were found on the side or the other side of the pole. Well, of course, I was talking gibberish claiming CFC is evil. I was figuratively referring to it as a thinking entity. Alright, let me just tell you that the information taken were from Earth Observatory.nasa.gov. As you can see, the ozone layer is a thin compressed group of ozone molecules. Okay, and right now there's a hole in it. A hole. Yeah. Now let me just go to the next slide. Now, this is the hole that I'm talking about, where as you can see here, the sunlight freely pass through the atmosphere unrestrictedly and unabatedly, hitting the ground and everything in its path. The sun here is depicted as a peeping Tom. Really nasty attitude by the sun. Okay, next slide. Okay. Okay. This slide is simply all about good ozone versus bad ozone. You can pause the video if you like. Both of them can be formed from VOCs, volatile organic compounds being hit by UV sunlight. Mhm. Now, when ozone forms at low heights near the ground, they are called bad ozone because it harms us. But when ozone forms high up in the stratosphere, they are called the good ozone because they shield us from UV light. Now, please give time to confirm this article's accuracy by visiting the website, which is written here. Now, what are the effects of uh, good and bad ozone? Uh, Shown here. Next slide. Yeah, these are the effects. Um, Skin cancer, cataracts, it destroys the body's immune system. Uh-huh. Number two is climate change. Okay, please see the Brewer-Dobson effect um, at Britannica.com. Now, this Brewer-Dobson effect uh, is actually forced atmospheric pressures created by smog, like pollutants, and they actually create extremely hot and cold weather patterns. Number three, it destroys the DNA, and yeah, mm, the ocean's ecology is also affected, forcing sea animals flee towards land. Okay, the highest mountains in the world were recorded as reaching only up to 7,000 to 8,000 meters. The real question right now is how are we going to solve this problem when the sky is so high? Okay, next slide. See, there's a difference of around 17,200 meters from one of the highest peaks on Earth, and we really need to bring a solution into the skies, literally. We have to reach for the skies. And how are we going to do that? I propose drones. Okay, if you're reading this statement is accurate, or is it? Well, it has been going on for some time now. And oh yes, the ozone hole is still out there. To think that I've been basking in the sun playing my heart out when all the while it was actually wreaking havoc to my DNA, damaging every cell in my body, I really thought it was safe. Did anyone remind me we're still in a pandemic, right? Okay, now this is a turbine, all right, turbine. What it does is that it allows flow of gas while creating propulsion. Why I brought this up? Well, my drone will need one. Now, my drone will have the capability to collect CFCs near the ozone hole. Now, it will also create some turbulence, thus sending them upwards, not through the ozone layer, but patch up the ozone hole with these CFCs. It will push CFCs towards the hole, where it can be exposed to the sunlight. Thus, also, instead of using propellers, turbines will be a better option. So we're not really interested in thrust generation here, but vortex generation. Next slide. Yeah, propellers, of course. Drones would need propellers. Now, uh, of course, propellers may be used as an option by manufacturers, but in the prototype, I use turbines instead. So this is this one is actually a typical drone design. Right? Now let me just go back to propellers. All right. Then okay, a motherboard. This is a motherboard. Okay. Like any computer guided systems, motherboards would be required. Control systems may be placed on the wings due to its slim design and compactness. Remember how I said earlier that we need to heat up specific regions of the atmosphere to break down CFCs. Now, I thought of Tesla coil and artificial UV light being incorporated in the design of my drone, and I call it the CFC Zapper. Now, another strategy is reflected surfaces and prisms, which will also be used to bend light emitted by the sun to, uh, well, after being identified by the drone. Mhm. Now, the drone that I am actually proposing has a spectrometer, yeah, and it will try to identify CFCs. Um, that's below the troposphere, of course, and then in proximity to the ozone hole, these drones of mine will also have prisms which will catch those powerful UV sunlight and angle them into position to beam them on CFCs. So let's go back to one of my slides here. Just give me a second here. So let's say this is the ozone hole, right? So this is the ozone hole right here, right? Now my drones will be flying around here, the edges of the ozone hole, which has prisms, right? Now the prisms and the reflected surfaces will beam, just put this here, will beam those powerful UV light from the sun. Let's say this is the sun, and those light will be bent to hit those CFCs. this was the template I used to show illustration. Okay. Now, manufacturers will have the option of making drones with specialized tasks. Now, they can opt to make one drone which will have a spectrometer to collect and analyze data, then return to base. They can also manufacture another drone. Now, drone 2 will create whirlwinds or vortex to patch up the holes with CFC, catering to UV sunlight because trapped CFCs must be exposed to the sun to decompose. So, also, they may opt to manufacture another drone. That would be the drone number 3. Now, drone number 3 hits the atmosphere to send CFCs higher while also breaking up CFC molecules in the stratosphere. Now, note that the drones will both be operating in the troposphere and the stratosphere. There will be some drones operating on the troposphere, that's below the ozone layer, and the stratosphere, that's above the ozone layer. Now, the next drone, or drone 4, waits for CFC analysis from drone 1 before zapping CFCs with ultraviolet lamps. And then another alternative course of action would be creating a drone number 5, which uses its reflective wing surfaces and angle the sunlight's UV rays towards CFCs in the troposphere. Well, that would leave the healthy ozone layer untouched, of course. Now, when cost consideration comes into play, it would be advisable to merge all of these attributes into one drone. Like this one. Just a moment. Alright. Now, my drone has all the necessary equipment placed into one. So it has movable wings, it has this turbines, there are 4 turbines, it has a UV lamp beside the wings, and it has a spectrometer here, a Tesla coil here. Alright. Now let me give you some more details about the drone that I've designed. Now let me just move on to the next slide. Okay. Now, as I've said, the drone will have a spectrometer, a gyroscope, a GPS, turbines, Tesla coil, UV lamp, prism, and a parachute. Now, what does each device do? Okay, spectrometers, which uses wavelength of light emitted by a substance, analyzes it and tells you what elements it is made up of. Now, note a typical spectrometer will have dimensions such as, let me just show you on slide number 24 and 25. And, well, the body of the drone will accommodate such requirement. And also, just a moment here. This one. So it has, usually spectrometers have a height of 15.24 centimeters and a length of 60.96 centimeters by 30.48 centimeters as its width. So it will be able to accommodate the device. Well, I also made an allowance on the upper deck for the GPS, the gyroscope, and all other control system devices here. So the spectrometer comes here, placed here, and then all other devices here. Okay. Now, as I've said, another strategy is reflected surfaces and prisms, which will be used to bend light emitted by the sun. Um, and also, yeah, this is the drawing of the drone. It doesn't look much, right? Well, that's because I have so little resources at hand. I don't even have the money to buy a decent software to work with. As a matter of fact, everything for any devices used in the making of this video was borrowed. Now back to the discussion. Okay. Next slide. Yeah, you've seen this one. Okay. This is angular movable wings of the CFC Zapper. Now, the idea of movable wings aim at focusing its reflective surfaces to receive the sun's rays and redirect them at CFCs trapped between or beneath the ozone layer. At the same time, its angular movement can focus the vortex of the turbines to maximize directional thrust. Okay. This is 45 to 180 degrees. It can actually swivel. And then we've seen this placement of the aforementioned parts and accessories needed by the drone. Yeah, it's an all-in-one multi-purpose device or equipment. So I think that's about it. See you in the next one. Goodbye.